All right, Dave. So what's the goal of this discussion?
The goal of this discussion is to
Hmm.
open your mind to some questions that you may have never known that you had, and to point out some things that you assume to be true that are clearly not true. I mean, we're taught that we live on a ball. Have you ever questioned it? Have you ever? No, you haven't. You were told before you had the ability to think. You were told by your teachers. There was a globe in front of your classroom. Sesame Street had astronauts on it and globes on it. And
Well, let me ask you one thing. So the experiment that they did in Antarctica, maybe we should start describing that,
It wasn't
right?
an experiment. It was an observation of a light in the sky. And that light in the sky is actually an impossible light that doesn't make any sense. So the question is, if you're trying to build a house, do you go and measure the ground or do you measure the sky? Right? You measure the ground. Looking up at the lights in the sky, you can, the globe model was based off of the angles of the lights in the sky. And we can get into that. But the lights in the sky make no sense. Let's get into it because I'll show you how impossible the globe is. It's totally impossible. Here's the thing. Everyone has the same story. When I was first, I was doing a conspiracy podcast and people brought up flat Earth.
Are we live? Right? Are you recording?
We're recording, sure, and I'll
Okay, go
start
ahead.
wherever. So, welcome,
Hmm.
Dr.SHIVA, or I'm on your show. I'm not sure which one it is, but we're having two conversations, two grown men having a conversation about the realm that we live in, and
And Dave, what do you put it up on what, YouTube or
YouTube,
Facebook?
YouTube.
Okay.
All right.
All right.
I normally let you, excuse me, I'm losing my voice a little bit, so I've done a lot of interviews. I normally you put it up and then I share your version. That way you get all the new views because we have a large audience.
Doesn't
Just like
matter. We're fine.
the,
You can put it
yeah,
up. That's fine. Either way.
I don't
Yeah.
care. I'm not monetized or anything.
Yeah.
I normally just
Yeah.
try to put it up. Um so you're brand new to this topic. I know that people have been hounding you in your chat saying, "Hey, have you looked into flat earth?" and you agreed to have me on. So that's awesome. Thanks for having an open mind. And
Well, I think about a year ago, David, just to give you an update.
yeah.
Uh, so there's two positions I have on this, right?
Hmm.
One is people should just collectively agree on an experiment, a very
Sure.
detailed experiment, and then people should go do the experiment and they should accept the results of that experiment. So it should be, from
Right.
a science basis, a verifiable experiment, right? That
Right,
follows,
right. So
follows a
so
scientific method.
yeah, you,
The
you're
other thing,
go ahead.
the other thing that I've shared is that um, for me, right, we know there are infinite number of things that the swarm lies about, many things.
Hmm.
So the issue is we could talk about this, we could talk about a whole bunch of things. My question also, my not question, is what do people want to do about it? You see?
Yeah. Yeah, yeah. So
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 and
we're gonna
and
get
so
into
to
that.
me, yeah, to me, one has to build a bottoms up movement of working people to address this.
Sure.
There's a lot of people grift off a whole bunch of stuff and they have no interest in building any type of movement to get to truth, freedom, health. You see?
Well, we're trying to
So
do that. We're trying to build that movement, and they're trying everything they can to stop us. Because this is the one that breaks us free from the matrix. You can't, there's a lot of things going on in the world with child trafficking and homelessness and wars and everything else. And people say, Dave,
yeah,
why are you focusing on flat earth? And the reason is because if you don't know where you live, who you are, what this place is, if you don't know that you're at the center of creation, that you have great power, then you can't do anything. You're lost in space, spinning out of control, and you're powerless. People think that governments rule over them. Nothing rules over you other than God, right? And so people don't realize they have free will. People just think that they're are stuck in this slave system, and the globe is a prison for your mind, right? And think about this: when people search flat Earth, they come up with this. This is stupid. Okay, no flat earther thinks that Earth is this, but this is what they want you to think. Like if you Google, "Hey, top 10 reasons the Earth could be flat," Google's going to deliver you top 10 reasons the Earth is a globe because they don't want you finding the true information of this world. You asked me before when I first got into it. I went into it with a bad attitude. I went in, I'm just going to disprove flat Earth, prove the globe. And I tried for weeks to find proof of the globe, but I couldn't. And the more I looked, the worse it got. And then I realized, oh my God, the Earth is not a globe. And then I was afraid to even talk about it because I'm like, oh my God, all of the other work I've done on all of the other deceptions is going to be discredited. But then I realized this is the truth. I have to do it. Back in 2014, when I was doing that, um, nobody was really open for a discussion on flat earthers. Like, you're nuts. But now people like yourself, other people are all doing it. You had an interview with Owen Benjamin. He fought it like tooth and nail. But now he's full on. He knows we don't live on a globe, right? I mean, this is 127,000 feet up, right? Whenever we send a balloon up, the Earth is white. Okay, it's white because of the thickness of the atmosphere, right? But NASA shows us these color graphic pictures of Earth. They're in Technicolor, right? Look at this light here. It's a local light. It's lighting up this area right here, right? It's darker over here because this is a local light. What is it? We don't know, right? But it's a local light for sure. It can be proven that, and we live on this realm. Now, we're going to be talking about where we live in this incredibly large system. And we live on this dielectric plane inside a toroidal field, right? And so we're going to be talking about 1% of what this world is. And that's where we live, on the 1%, the dielectric plane. The Earth is supposedly rotating at 1,000 miles an hour below this balloon. Right? 1,000 miles an hour to the east. This balloon is disconnected from the Earth. It's nearly in space, if that's a real thing. And when it came down, it landed east of where it took off. It should have landed, it was up for over 3.5 hours. It should have landed 3,000 miles out west in
What
the
balloon are
ocean.
you talking about, Dave?
This shot right here is just a weather balloon, went up to
Yeah, so let's just look,
120,000 feet.
let's take time out here. Let's just take
Okay.
first principles, okay?
Yep.
Um, let's just go to very simple first principles.
Sure.
Okay, and let's go to the basic scientific method. So let's review what the scientific method is. What is the scientific method?
Observable, repeatable, testable with an independent variable and a fixed variable. Something that's done in
Well, no,
nature.
that's not what the scientific method. Let's just follow what is the scientific method. What's the first step in the scientific method?
You tell me where you want to go with this.
Well, I think we need to follow the framework, what we're going to use to get to truth. So
Sure.
the scientific method, because otherwise it's just everyone's just talking over each other.
Sure.
The scientific method says first you come up with a hypothesis, step one.
Sure.
You can have a hypothesis that the Earth is round or the Earth is flat or the
Sure.
Earth is
Sure.
whatever, multidimensional. Okay. It's not Earth, it's maybe 15th dimensional, whatever that is. Okay. Then the next thing you do, you agree that you're going to do an experiment,
Sure.
the methodology of an experiment, step two.
Hmm.
Then you gather data from that experiment.
Sure.
Okay. And you agree what data you're going to gather.
Sure.
So once that's step three in the scientific method, once you gather that data, you organize that data, and then you produce a model from that data, what that data gives.
Sure.
If that data matches your hypothesis, you say, great, I believe I have something here that's true.
All right, let's
And
do
then
it. I have a I have,
let
a,
me
I
finish.
have
Let me
one right
finish.
here. Sure.
Let's just go through because a lot of people didn't learn this in third grade,
Yep.
which is, and I don't think the educational system teaches this anymore. And then if you prove that your data and that model matches your hypothesis, then you would do another experiment. And you
Correct.
iterate over and over and over again.
Correct.
And if you say that it's reproducing, and if you say at this point in time, based on the data we have a law that the Earth is XYZ. Okay.
Got it.
So let me give you an example so let's just set the framework of science here. Or we agree the framework's not true. First, in biological and engineering systems, you manipulate a system of some kind, then you measure the data from that system, and then you mine that data, and then you model it. It's called the four M's.
Okay.
So manipulate, measure, mine, and model. If the model matches your hypothesis, you continue. If it doesn't, you have to throw away your hypothesis was false. It doesn't matter
Right.
whether you're wearing a red hat, a blue hat, doesn't matter how wealthy you are, it doesn't matter if you're good looking or not, you're just fucking wrong.
Yep.
So, I
So I
think
got
this
one
is a
for you. I have one for you, an
no, no,
example.
but wait. Do you agree this is a scientific
Yeah,
method?
100%. Yep.
Okay. So now if someone says the earth is round,
Yep.
okay, or someone says the earth is flat, they have to propose an experiment
Let's do it.
that everyone agrees to,
I
okay?
got it.
And then they go, so before we go there, there was a recent experiment that was done in Antarctica,
It
right?
was not an experiment. It was an observation of a light in the
Okay.
sky under very sketchy circumstances. Let me show you an
No,
experiment.
but that too, but
Yeah,
Dave, that is an experiment
it's
because
not.
it is. An
It,
experiment is where you propose,
hmm
even how you propose to observe data is an
hmm
experiment, okay? You're saying, I'm going to do this, this, and this. I'm going to collect this data, and then I'm going to do this, this, and this to mine that data to model it.
Right.
So I haven't even looked into the math of this or any of this. Um, you know, I have 4 engineering degrees, right? And this is what we do. Engineers can't lie like scientists can. Engineers have to build stuff that works.
Yep.
And so we have to live with the reality of natural laws. Otherwise, you can say all the shit you want, but if something you build doesn't work, it falls out of the sky.
Right.
So if you go to the experiment that was done, and I believe some non-flat earther and a flat earther was involved in that, can you describe what
Yeah.
they agreed to do?
Well,
What did they
I'd
agree to
rather
do?
talk about the shape of the earth than the lights in the sky that we nobody knows what they are or
No, no,
how
no, no,
far
no,
they are.
no. But
So
just to educate people, some
yeah,
guy agreed to do this experiment with this
no,
guy, right? What
no,
did
they
they?
did not. No
Oh,
one agreed to do an experiment. They agreed to go make an observation of the sky
and
and see what it
and what
told
was your
us.
right? But that's an experiment, Dave.
Well, it's not because the lights in the sky do not dictate the shape of the floor. Like I look up at the lights in your ceiling and tell me if they tell you what shape your floor is.
No,
Here's an
no, 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 no,
experiment.
no.
Let me show
But
you an experiment
let's not
here.
talk, Dave.
Yeah.
Let's not talk analogies because analogies in science don't work. Let's
Right.
talk
So I
not in
got
the
you. So
abstract.
let me show you an experiment right here. If something doesn't curve, then it's what?
What
If
do you mean if
something
something does
if
not?
something does not curve, then it's flat.
Well, you have to define what
Okay. If
curvature is
something
first.
has no curvature, then it's flat. Okay. Here is a lake, right? And the we got a camera on a frozen lake. So large bodies of water at rest lie flat when they
Yeah,
get
I
cold.
can't make out. No, no, Dave, stop. I don't know what you're showing me here,
I'm
so let's
going to
just
show
stop.
you. You have to give me time to show you.
No, no, but what I'm saying is I haven't seen this experiment. You're showing me
But I'm going to
pictures
show
on.
you, and then you can verify everything, right? And there's tons of videos, so you don't have to go and do it yourself, but you can go do it
Well,
yourself.
what I'm
So
saying, Dave,
yeah,
time out. Okay. We agree on a scientific method. Okay.
yep,
Look, you've done this with a lot of people. That's great. Okay. I want you to sort of just clean the slate.
yep,
Okay. And just think in a very clean way. You're talking to an engineer
yep,
who actually has to build stuff and who knows laws. Okay.
right,
I do. All right. So let's take a clean sheet of paper. We agree on the scientific method. Okay.
yep. So let me show you my scientific experiment right here. Actual
Right. Let me finish.
measurements.
So first, your hypothesis is what in this?
The
Give me the exact
hypothesis is
hypothesis.
if the Earth is a globe at the
Mhm.
size that they tell us, it has a curvature rate. We know what that rate is based on the Pythagorean theorem, and the best
Right,
formula.
but
What?
let's just stop right there. Which are you talking about? So there is the center of this circle. There is a
There's a radius.
there's mantle and there's a solid mass, and there's an atmosphere around that, right?
Yep.
The mass that you're talking about has various elevations around it
Sure.
as you traverse that.
Right. But if we go over water, water lies level, right? The water does not curve, right? On a ball, they tell us that at the equator, it's 24,901 miles in circumference. So that would be a curvature rate of about 8 inches per mile squared. That actually is in
Well,
favor.
the water also has surface tension.
Well, small body, small, like a drop of water has surface tension, but a large body of water, anything over a gallon of water, will lie flat at rest, right? And that's fact.
No, I don't. No, I have to think about this.
Yeah.
You're
So
saying it lies.
Yeah, yeah.
No,
So
no, wait,
so
wait, stop. Time out, time out. You have to think about that because you have gravitational forces,
sure.
okay, which affect bodies of water, right?
So if the Earth is, let me help you with that. They tell us the Earth is 70% water. So that water can't be flat. It would have to curve around the Earth. It would have to curve if the Earth
Well,
is a ball,
what I'm
correct?
saying is that well, no, I have to do some thinking about this because th when you look at a object it's a deformable liquid, okay?
Yeah,
It
but
can undergo
water, calm
yeah.
water at rest lies flat,
Well, but you
and it
have
would
different
have to conform to the curve of the Earth. Otherwise, it will be a sheet that shoots off into space.
no, but what I'm saying is the nature of that curvature, okay, or
Mhm.
that deformation because it is a elastic fluid will vary. You agree?
No,
Over
no, I
time.
disagree because large bodies
Why
of
won't it
water
vary?
at rest lie flat, right? So if we had a lake a mile long from one, if you're standing at one
But
end,
David, you have different forces on objects, right?
well, you're just talking about the alleged force of gravity. But when water is at rest, it lies flat. That's how engineers measure the level is
Right,
with a
but so
water
you're
level.
assuming there's no other forces at all.
Well, when you're looking at a lake or a reservoir or something where the water is calm, it's lying
So
flat.
in this model, in your hypothesis, it's more than just a hypothesis. You're excluding gravity. You're excluding any other
I
forces
certainly
on.
am. I certainly am. Let me ask
Right.
you a
So,
question. If something is moving at a constant speed, forget whether the speed is changing or not, but it's turning, it's not going on a linear path. That curve, that turn is equal to acceleration. Do you agree with that?
what I'm saying is that you have to lay out the problem very clearly. You're
I'm
being
I'm
very
I'm
to your
trying to
own
lay it out, but
detriment.
you haven't
No, no, but
allowed me to show you yet.
no,
So
but I'm trying to say, Dave, you have to
yeah,
lay it out very clearly because all the stuff out there, I'm willing to look at it in a very clean way,
sure.
but I don't really care for all the shit out there. What I'm trying to say is let's define the problem
Yep.
in a very precise way. And
Okay.
the problem definition is very hard to do.
Yep.
So the problem definition needs to be done very accurately. You have to lay it out saying, these are my assumptions, or these are my um, initial variables. And
Yep.
based on these initial variables, I'm making this hypothesis. So what are your initial variables? There is no gravity. That's one of the things you're just bringing up now.
Well, that doesn't have anything to do with this, but we can get into what gravity is if you
No,
want.
when you David, forget gravity, forget round Earth, flat Earth. I'm just saying when you start with the scientific method, you come with a hypothesis. Then you go down to the methodology that you're going to use to validate your hypothesis, what you call the experiment. Then you're going to say what data I'm going to collect. So if we were to take a fresh, clean sheet of paper, we'd write down what is a hypothesis. So a
Hypothesis is
hypothesis
that
you're
the
saying
Earth
is
is flat.
but it's more than that because you're saying that the Earth, but because then you're going to propose an experiment. Your experiment is based on not just being the Earth is geometrically flat. You're basing that on some other, all additional hypotheses.
Well,
The-
I'm basing it on the fact that the globalists, the science, the today's science that they teach us from the Rockefeller funded textbooks, tell us that the Earth curves at 8 inches per mile squared. That's what they tell us because we live on a ball 24,901 miles around. But the Earth is spinning at 1,000 miles an hour, 1,040 to be exact, right? At the equator, slower in other areas because it's making a smaller circle as you get closer to the alleged poles, right? And then it's orbiting at 66,600 miles an hour, speeding up and slowing down. Average speed 66,600. All of these are curved trajectories. We're also chasing the sun at close to a half a million miles per hour. So you got this lumpy rock surrounded by water, surrounded by high pressure air, adjacent to a void of no pressure called space. And it's making four different motions at once, and none of it is ever felt anywhere. No one ever can measure it. No one can ever see it or anything. But when you go out into nature, you see stuff like this, right? You
yeah, I
see,
don't care about all this. I'm
all
just
right,
saying, let's just take a clean sheet of paper. None of this is, I like math
right.
and
So
experiments. an
I
engineer.
have one for you if you allow me to
So what I'm
show it to
saying
you.
is, all I know, David, is that it is very difficult in science or engineering to make something, build something, validate something.
Sure.
And it takes great amount of effort to someone to have made this. Okay. It
Let
takes, I have great value for people who make things these days. Okay.
Sure.
So we have to honor that. So all of these statements that people just make, whether you make it or others, I don't like I do actual experiments even go against the scientific establishment.
I
Okay.
get it.
At the end of the day, I win because I get data. It matches the hypothesis I made, and I have data to validate it.
So if
Okay.
you
And
allow
then I
me to show you my data that will validate my hypothesis, and you
no,
can tell me where I'm wrong.
but I want to get the hypothesis clear. The hypothesis you're saying is if you take 2 points on the Earth, any 2 points anywhere, that you're saying that it is not going to match the curvature of X, the
Correct. Correct.
X. That's so let's just get it very clear, okay?
Correct.
But the
Correct.
hypothesis you're saying is that I would be more precise if this is what you're saying. If you take 2 points, the the distance between those points, if it's an arc, right? The circumference of the Earth is, let's say, 2 pi r, whatever the radius of the Earth is. The arc of that particular point, right, or that the arc length, if it's in fact following a radius, is going to have a certain distance at any point based on that
Sure.
curvature, right?
Sure.
Now, this all depends on the you have to measure this very carefully, and you have to also look at there's local changes within any 2 points, right? Because the
Well, that's why
surface
we
is
do it. That's why we do it over water or the Great Salt Flats in Bolivia. We measure there,
okay.
and
So,
those places are
but you're
level.
saying there's 2 points, and then your experiment is going to say that we're going to go measure between these 2 points,
Correct.
which are, and you're going to choose a location, okay?
Yep.
Which what you're saying is what is the location you're choosing here?
So this is a reservoir, and it's frozen, and then we have a camera 6 inches off the ice. So it's
Hmm.
at night, so it's hard to see. But we put these lights out here. Okay, 4 lights, right? 8 miles, 7 miles, 6 miles, and 5 miles. Now, it doesn't sound like a lot, but according to the globe math, what they tell us, right? This one should be more than 30 feet below the curve, behind the curve, right? This one,
Well,
22 feet.
let's just do the math ourselves. What
Yeah.
is the if we just look at that, what is the curvature? I mean, I can get out a calculator
The
here.
curvature is you can go to curvature calculator. Um, uh,
Mike, and let's just do the math
yeah.
ourselves.
So it's
So
8 times 8.
hold on. So I'm going to bring up a spreadsheet here. Okay.
Yep.
So what is the curvature from point A to point B?
The curvature that it's supposed to be is eight
Yep.
inches per mile squared. So you got 8 times 8.
8 inches. 8 inches is the curvature per mile squared.
8 inches per mile squared. Because if it was 8 inches per mile, that would just be a ramp, right? It's exponentially curving faster and faster, right? This formula is a parabola after like 2,000 miles. Nobody can see 2,000 miles. So we're just doing this. It works. It actually gives the
No, you're
globe
saying if this point is zero, the parabola is going like this.
correct. And after
Okay.
about 2,000 miles, it's not valid anymore. But
So
up to
why?
2,000 miles, it's within
Right.
a
So
couple of feet.
right, but if you just take a simple parabola, okay, just
Yeah.
basic like algebra, let's say here's flat and here's the y-axis down this way. So if this
Mhm.
is 0, comma 0, you're saying it's going to go like this, right?
Yep.
Okay. So what is the equation of that curve? Y equals what? Minus what x squared?
It's the Pythagorean theorem, right? It's eight
Well, it's not
inches.
Pythagorean.
Right.
It
Well,
has to be,
you can measure the radius, right?
yeah, but what
So
is the equation? Y equals minus what is k x squared? That's what I'm asking.
uh, you know what? The way I look at it is that we just use the Pythagorean theorem, and it works out.
Not the
Uh,
Pythagorean theorem. It's a parabola. If you're saying it's a curvature, right?
yeah.
If this is 0, right, it's going to curve like this. So what is the equation? Y. I'm just asking what's the equation? Y equals minus
Here,
something x squared. What is that?
let me show you the easy way to do it. All right. Um, where is it? Okay. So
Well, that's one of the easiest ways. It's just y equals Just simple
Right.
algebra.
So we have a squared plus b squared equals c squared. It's a Pythagorean theorem. So if we put that on a globe, they tell us the radius of the Earth is this is the radius, and we went out x distance. This would be the drop right here. So they tell us the radius is 3963, another made up number, right? But that's the official story. So this is not the scale, of course. So we got our radius. If we went 100 miles out, we can square the numbers and figure out what the drop would be, right? So the
No, I
hypotenuse
don't
would be
follow. No, look, I got to understand it simply. You just said it's something x squared, and you said it's a
three
parabola
3963
squared.
times
Yeah,
squared times 100 squared
right. And then the
equals the
height,
hypotenuse of 15,715,000 feet.
but then you have to take the square root of that
Correct,
to come
right?
to which point you're out in outer space then,
So we're up in the air, right?
right?
But if you subtract the radius from that, it comes out to 1.2615 miles, which is the drop. 1.2, which is 6,660 feet. At 100 miles, there would be over a mile of drop if the Earth was curved, right? The
Let me look. So you have go back. Just go back. Okay, so hold on. You're saying the radius is 3,963 miles. You go 100 miles, and at that point, if the Earth was flat, right? This
if the
was
Earth was
flat.
curved, if the Earth was curved, we'd have the difference of the radius
Yeah, but
from
before you go,
here to here.
no, but that's a flat Earth model.
No, that's
The
the
Earth,
globe model. I'm calculating the drop on a globe.
no, no. If you were at that point and you were flat and you came out, you want to try to find out if you were going from the. I'm saying that is if the Earth is flat, right?
No, this is if the Earth was a globe. If I went out straight and on a straight line from the
Yeah.
tangent of my feet and I didn't follow the curve, after 100 miles, I would be 1.265615 miles high, which is 6,600 feet. Right? That's how much curve there is. At 10
You're
miles,
saying,
there's
so you're
66
saying
feet of curvature.
if you just flew a plane straight,
If I flew a plane straight and didn't follow the
yeah.
curve, right? It didn't follow the curve.
Wait, yeah. So let's just say you just draw. You should be at. So you should be. So 3964 is that 0.26 minus 3963. Yeah, you should be from that point. Again, you have to be careful where you're measuring that point.
I'm measuring from
Okay?
here straight down towards
Right.
towards the center of the Earth.
Well, no, no, no. I'm saying that distance is from the surface to the point that you're at, the 1.2615 miles.
See here?
Yeah,
Right, because I went out straight. I didn't follow the curve. So now I'm up
that's
in
what
the
I'm
air.
saying.
If an
But what I'm
airplane
saying is,
didn't curve, it would fly out into space.
right, but what I'm saying is you have to be very careful on the measurements. When you write your research methodology out, you have
Mm-hmm.
to write this very precisely because in science, an experiment can be reproduced by anyone. You publish this, someone else should be able to go reproduce it.
Everyone can. It's been done 1,000 times. We have thousands of
I
measurements.
don't care. I don't care about any of that. I want to do this from scratch, okay? Because
Right.
I like going and proving stuff. Just go back. Go
Okay.
back. What I'm saying is, Dave, if you go back to no the previous
I'm
diagram,
going. I'm going. I'm going. Go ahead.
right. So if let's say you want to use a lake or salt flat plain somewhere, okay? So if I start a plane straight and I just go straight, okay? And I just fly that plane straight, right? I don't even take off. That's what you're saying. If
Yeah,
I
the
stay
Earth should
flat,
drop out from underneath you if it's curved.
right. So if I just go straight, okay, and taking into account, if I just go straight, meaning straight into that 100 mile on a flat surface, and I go 100 miles straight, um, I should be, if the Earth is round, according to that, after 100 miles going straight, I should be 1.265 miles from the surface. That's what we're saying here.
That's what we're saying. Yes. Now, do you know how planes stay level? They have a gyroscope on a 3-axis gimbal that spins up and holds rigidity in space. So as the plane turns goes up and down, the gyroscope always stays level. It always
Hmm.
stays level. It holds rigidity in space based on their initial airport. If you flew halfway over the globe, the gyroscope would be vertical. It's not going to curve with
No,
you.
forget all of them. Let's just keep it keep it simple, stupid principle. Okay. You get a
Mm-hmm.
flat surface of 100 miles, according to this
Mm-hmm.
hypothesis you're proposing. And if I
Mm-hmm.
were to just fly something straight,
Yep.
if the Earth is round,
You'd end up in
um,
space. You'd be 80,000 feet in the air in 1 hour.
well, I should be 1.2615, which is
Oh, for
5,280.
just 100 miles. Sure. Sorry. I
Yeah,
thought you were
yeah. So
talking
let's
about.
just get that number right, which is 1.2615, 1.2615, 1.2615 times 5280, which is the number of feet in a mile. So you should be at, that's interesting, 666.
Yeah. That's another thing. Dude.
Okay, anyway,
What,
so
what,
well, in this model, you should be at
yeah.
6,660 feet above the ground. Okay, that's what
Yeah.
we're saying. All
Can
right.
I can I just show you a little side note? Six times
Yeah.
six times 600 is the circumference of the Earth. It curves at 0.666 inches per mile, 66.6 thousand miles per hour around the sun. Six times 60
Yeah.
is it's just, and there's hundreds more of these. Okay. It's
Yeah,
kind of
but
weird.
let's, I don't care about all that.
Go ahead.
I care about actually doing an independent experiment. Go back.
Got it. Yeah. Yeah.
So go back to
I'm
that.
going.
Yeah.
I'm going.
So just to be clear, if you apply that and I file, now I have to be able to fly that plane in a flat thing. That's very important. Okay.
Yes.
All right. That's an interesting thing with gravity. Okay.
Can I
Um,
show you an example of a pilot that did
no, no, I don't want to go there yet. I just want to
okay.
I just want to intellectually understand this in my own. I don't want to see any other data. I'm looking at it, clean sheet of paper.
Okay.
You and I are putting together an experiment. The hypothesis is if I file 100 miles, are you all set? Okay. If you just file something very flat on a flat surface and you're proposing after 100 miles of flight, and
Hmm.
we should figure out how fast you should fly, right? We should write all this down. Okay.
Yep. We've done it.
Yeah. But it should be a very simple experiment that anyone can execute and it
Right.
cannot, and it can be reproduced. Reproducibility,
Right.
reproducible predictions, Dave, is the definition of evidence in
We,
science.
we've done it.
Reproducible.
We have pilots that
We've
all
done it,
talk.
but I'm saying,
Yeah, yeah.
wait, stop. Because, you know, I come from this institution on the street. If we were to lay out an experiment, I would say, let's go do this at this location, do this, this, and this, and this, like a formula.
Let's do
And
it.
any MIT nerd, any physicist should be able to do that experiment independent of you or I, and they should get the same result. So according to this, they should get a result of 6,660 feet. They
Correct.
should be above this flat area. Agreed?
Correct.
Okay, so let's just stop right there. Just stop right there. Okay. Where is a place? We don't even need to go 6,660 feet. You can go much shorter than that, you know? Where is a place that you propose that this experiment should be done?
What, flying an airplane straight and level? They do it every day. Every single flight flies straight and level. You look at all the
No, no,
flight
no, no, no,
data.
no, 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 not they. I'm saying you and I, and we get
So we get a private
500
jet.
people.
Every single flight flies straight and level. Airplanes fly over the earth plane. They do not nose, their nose up 2-3 degrees the whole time. So as you're flying over this ball, how are you going around the ball with the nose always up?
Right, but David, I don't care about all that. I'm just talking about an experiment that can be reproducible,
All right.
that
Can I
any idiot can do,
Right, I
that
got
you
it.
can
This is
write it
one
up
that
as a,
any idiot can do. Let me just finish this. Okay.
yeah.
So I rounded down because they always, oh, refraction, things
So,
refract up.
yeah, but where are you choosing the location? I want to write down this
This
research.
is just a frozen lake. We've done it over Lake
Where?
Balaton.
Where?
This one, I don't know exactly where this one is. I forget, but we have a whole bunch of ones we did. We did a laser, 26-mile laser test over Lake Balaton, and it showed no curvature. And the curvature of 26 miles is far more than this, right? But these are rounded down, giving the globe every benefit of the doubt. So what does this mean? So if we look, if the Earth is flat, it means the camera's here and it could see all of these lights and they all line up. If the Earth is a globe, At 6 inches, the horizon should be about a mile away. So then you have the tangent of the Earth. And all of these are refracting up the perfect amount to appear to be at this tangent. That's what you have to believe if you believe the Earth is curved, that they're refracting up and they're tricking you. They don't refract higher, they refract up to the exact level of the tangent of this viewer. That's what you have to believe. That's crazy. The reason you can't figure it out is not because you're stupid, it's because it's stupid, right? The globe is the dumbest thing ever. Once you understand what you've been believing your whole life and have never questioned.
Yeah, what I'm saying, Dave, is there needs to be an actual specific location,
Yeah,
an actual set of steps
sure.
that everyone agrees to in a scientific methodology. You're saying if you go back, you say we are going to move an object 100 miles
Mm-hmm.
in this direction, and after it moves the object 100 miles in this direction, we're saying that its distance from the surface of the Earth needs to be 6,660 feet.
Which it
That's
won't
your
be.
simple
But
experiment.
they never. No, but here's the problem: they won't be, and they claim that gravity is pulling you around the curved air of the Earth. Okay, that's not the case at all. An example would be this, right? The faster you go, the faster things curve. So here's the new SR-72 Blackbird, right? This thing goes 4,000 miles per hour. 4,000 miles per hour, right? So if it flies out and it's 6,000 miles out to here, right? 4,000 miles per hour, the drop would be 4,000 miles, right? So that means it's dropping at 1 mile per second. The SR at the speed that it flies over the course of an hour, it has to drop at 1 mile per second, which is faster than free fall. What would happen to anyone on this plane if it's curving faster than free fall?
That's not true. You have to do the inertial, you have to calculate the inertial system on that plane. That's not true because that's in
One
its own.
hour, it drops
Dave, that's in
4,000
its own
miles.
relative.
I
No,
mean,
that's in its own
it's
relative. No, that's in
okay.
its own
Yeah,
relativistic frame.
right.
Okay. So
Sure.
you can't go there because you're gonna screw yourself. I'm just saying you need to make this experiment if you want to do this so simple
Right.
that anyone can do it, any school kid can do it, and they all should
Mm.
get the same data. So that would be my
Well,
recommendation.
how is a school kid going to do
I
this?
don't
So,
have,
so
I
what
don't
are you
have,
going to?
I don't have a skin in the game. I don't have any
Yeah.
skin in the game here.
Well, but here's the thing. The thing is,
Mhm.
there's so much evidence that the Earth is not curved. There's so much evidence that you can't have high pressure next to no pressure without a container, right? When pilots are coming into an airport, they say, okay, we're about 125 miles out. They figure out how much they have to drop per minute to get to the airport, right?
Yeah, Dave, I've heard all this. What I'm saying is
You've
all
heard
of this
this.
stuff. No, what I'm saying is I've heard all of this stuff. My point is that still missing among this community is a proposed experiment that everyone agrees to.
I
You
have
write
one.
it up like a scientific paper. No, go back to the one you just said. That's
Which one?
it's the one you just said. You fly for 100 miles, and then after that you check the distance. It should be
Okay.
6,660 feet.
But what happens
What
when
I'm
it's not?
saying, well, if the experiment works, that means you're wrong.
So, no, no, no. If you fly 100 miles and
Yeah.
you're not 6,600 feet, does that mean the Earth is flat?
If you're proposing that you make a hypothesis, let's follow the science. That's why I started this conversation.
Yeah.
Let's follow a rubric that we all agree to, whether you're on this side or that side. This is how science gets done.
Right.
Okay. So if you followed that, so you would write hypothesis. It's like third grade.
Sure.
Two, this is the methodology I'm proposing. And the methodology, as Mr. Gerald Walker, my ninth grade teacher, said, has to be written very explicitly. Great teacher.
Sure.
Okay.
Sure.
Step one, step two, step three. This is where we go. This is what you do. This is the machinery we use. This is the beaker we use, everything. You have to write it down very explicitly so everyone can reproduce it. And you have to write it down very okay, if we're going to fly a drone, it has to be this drone.
Can I run it by you? Can I run by your methodology here? Here's my hypothesis. We start a plane out here and we're on the salt flats or wherever. We have 100 miles of.
No, but what I'm saying, Dave, is before
I,
you
I'm,
say
My
A,
hypothesis is that I fly 100 miles, and if the Earth
yep,
is a globe, I should be 6,600 feet in the air if I
it should
fly
be.
straight
Yeah,
and level. Okay.
yeah.
But when I'm not, that matches the flat Earth model. So now what do we do?
Well, now you have an experimental piece supporting your hypothesis.
Sure.
Now you would do another.
Every single flight every day does that.
I don't want to hear. I don't want to hear that. I want
Okay.
to. I want what I'm saying is, if you want me to help facilitate this, I will.
That'd be
Okay.
awesome.
I'm saying that why don't we get, and I'll sponsor it right here in Cambridge. I have a big office here,
Okay.
big room. We can hold a conference. Okay. Let's bring 20 people from physicists from MIT, Harvard, right here. I'll call a bunch of people up. You bring 20 people.
Okay.
I'll help chair this meeting, and we'll use all the whiteboards I have right here in our big room here. We have
Awesome.
4,000 square
Let's
feet
do
here.
it. Let's do it. That'd be awesome.
And we will propose this experiment, and everyone go around the room and agree to the exact experimental dynamics, exact equipment, everything, how
Right.
we'll measure everything. Okay? So we have to agree to that experiment. All
That's
right?
one experiment.
Once, let's just start there. Let's just
Okay.
start there. Let's just do one fucking experiment right, okay? That everyone agrees to. And then we go do that experiment, and you will have, I'm proposing you do 20 iterations of that experiment. On each team, you have a flat earther and an MIT physicist, okay?
Okay.
Or a non-flat earther. And so therefore everyone's checking each other, and everyone's supposed to follow that protocol that we all agreed to in my room here in Cambridge to the letter. And if someone doesn't, that data gets thrown out because that means someone's trying to violate the agreed upon manifesto of how to do this research.
Here's the
So
problem. Here's the
oh, no,
problem with.
no, let me, this is not, no, wait, there's no problem. So
Okay.
if everyone agrees, you agree, and, Jim Williams, who's the head of the physics department of MIT agrees. You guys both agree to our mechanics department, okay? You both agree, and I can bring these people in. Everyone agrees. And we have two teams, okay? 20 teams, and everyone goes to the exact same place with the exact same equipment and then gathers the data. And everyone brings the data together and we put it up on a whiteboard and we look at it and we publish it openly. We'll get a journal to accept it, okay? So now you have data. First paper, and maybe that's showing that agrees with your hypothesis. Everyone comes out to plus or minus 5%, 6,660 feet off the ground. It's published. Done. Now, people will say, great. Other people say, oh, you missed this. Let's say you're right. The people on the other side will say, oh, you missed this, this, and this. We'll say, great, come back. Let's meet again in Cambridge. So if what you say is true, let's update. Now you do. So what's your hypothesis? They're going to say, well, that was wrong because of dot, 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 dot. And we all meet again. We say, okay, that could be true. Then what experiment would you propose, or how would you advance this experiment to measure the anomaly you're saying? Great. Go out again. Do it again. Guess what? It still comes out to the same answers. Now you do that over and over and over again with this experiment, with one singular experiment, and you get data and same set of people to validate it. That's how science is done. I can say, this MV25 product where we mix two ingredients together lowers inflammation. Bullshit, right? Marketing. Well, I get these two ingredients. I find the exact dosages. I find exactly which molecular target it hits, and I prove it over and over again. I have the exact quantitative prediction, and then I test it in an environment, right? That's science. It doesn't matter. It doesn't matter if you're a PhD out of MIT, if you're not. If the data proves the hypothesis, that is what you have to suck up to. So that's what I propose.
Okay.
Because that's what I said.
No, I got it. So just jumping forward, we do this. We do take these flights. They do not end up 6,600 feet because there's 10,000 flights every single day that don't do that. So now we have that data. We did it ourselves. Forget all the commercial flights, all the private flights.
20 people do it. 20 people do it with two teams.
Yeah.
One who are pro flat earth, anti flat
earth. And we're all going to agree that it's not going to end up 6,600 feet.
No. The next step we do, Dave, once we get that data, we go find a applied physics journal and we publish it.
Yeah. Good luck with that. No, I get
No,
it.
no. If the data is there, I'll help you get it published.
Okay.
Okay. I know how to write these papers.
Right.
And if there's many journals and you publish it, here's the data, and we do a video on it. Okay.
Sure.
That would be taking it out to the community, and then people have to attack the paper, find out what the flaws were. They'd have to attack the MIT guys and you guys. Okay.
I got
Because
it. I know the
so,
argument though. They're gonna proclaim that the pendulous veins in the gyros are accounting for the curvature of the Earth. But the problem
but
is,
Dave, stop,
yeah,
stop, time out.
yeah.
When we meet, remember step one, hypothesis, step two, research methodology. When we meet here in Cambridge and we sit around our big little conference room we have here,
Mhm.
everyone's got to put that out there right then. They can't come later. You see? When we design the experiment, they would have to design the experimental design is key here. What is the experiment? It's like the
Michelson Morley.
Michelson Morley experiment,
Yeah.
right? So you have to design the experiment correctly. One of my great heroes is Richard Feynman. I mean, Richard Feynman would have theory, he would experiments, and he would prove, and he would say, look, if science is real, if the data doesn't match your hypothesis,
You
it
have to
doesn't
throw
matter
it
who the
out.
fuck you are.
Except in cosmology, they can be off by 10 to the 120th
But
power,
no one
and they
has
just make it
done,
up.
no, but stop. I'm proposing I will help facilitate, get a guy with 4 degrees from MIT, okay, who's bridged both these worlds.
Sure.
I will call a scientific conference on this.
Okay.
And we take that experiment that you just said, because from your standpoint, hold on one second, Dave. Hold on one second. Hello? Hello? Is this Alvaro? Okay, Alvaro, I'll be right out. Give me 5 minutes, okay? Oh, 10 minutes. Take your time. Okay, thanks. Bye. Um, Interesting. We're talking about flat roofs. We have a flat roof, rubber roof, and we have to figure out how to do certain maintenance on it. But anyway, Dave, what I'm saying is I don't care all the shit that's out there, okay? I like to take things completely fresh. When I did the election fraud work, a bunch of people said that I went and looked at the machines. I found the research. I did the analysis. I found a paper which said that the voting machines have a piece of a software in the machine which allows them to multiply votes by weighted race feature. Found it. Unequivocal. Okay. So I like doing, and then the reality is Trump and those guys used my material to talk about election fraud, but they didn't do anything. Okay. Same with the backdoor portal to Twitter. I unequivocally in court proved that the government has a backdoor portal into Twitter. Okay. Elon Musk and Tucker Carlson all concealed that. So whenever the truth comes out, you have these people willing to conceal it. But I'm saying up front, let's get everyone here. I mean, I'm in the heart of science and technology. Right down there's Harvard, over
Let's
there's
do it.
MIT.
Let's do it.
So I'm saying and then if the experiment is right, then you can do another experiment and another one, and you build a body of work. Eventually, that's how you win this game. When I did the same thing with the genetically engineered foods, I very quietly published one paper showing that what is the C1 metabolism pathway. Got it published. Okay, very quietly. Next one, I showed what happens when a plant undergoes stress. Published that over here. Then I said, what happens when you genetically modify a plant? Oh, it upregulates formaldehyde, downregulates glutathione. Okay, but I had built it on all this stuff. By the time it came out, these people were fucked because I'd gotten these other things peer reviewed and published. You say?
Dr. Zira, I
So
think that there's better. There's other experiments that are better out there that would just take a little more
whatever
time.
it is,
I got
whatever
it.
it is,
The
whatever
airplane
it
one.
is,
The airplane one is done.
you tell
And
me when you want to do a conference here, a
well,
scientific
my
experimental.
suggestion is you're brand
Yep.
new to this topic. I think you need to look at a little more of the evidence before we decide what experiment would be best.
No,
Right?
but let's define evidence. Evidence is reproducible predictions. You predict something, you're able to reproduce it. That is a
Yeah.
definition of evidence
Right,
in
right,
science.
and there's lots of that. I've got some better
Right.
experiments
So
that are
no,
doable, easily done in one day, easy and definitive. Right?
no, but Dave, the reason this controversy is going on is whenever you have controversies in science, you have to have both parties coming together and designing an experiment, particularly in something like this,
I got one. I got
agreeing
one
to the
better than
experimental.
the flight going straight. I got
What's
one.
that?
I have a better one that's done on an airplane. Um, my suggestion to you is on my website, flatearthdave.com, it's a picture of me and it says crash course. There's a bunch of videos there that you'll never find on your own because
But I don't care
YouTube's
about
hiding them.
that.
But
No, but I don't
it'll
want to do
teach
that.
you a little more.
No, 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 but I don't need that. I go to first principles.
Yeah.
Let's just go to first principles. You brought up the Pythagorean triangle. That
Yep.
is first principles. A squared plus B squared equals C squared. Okay? The circumference of an earth of a circle is 2 pi r. Pi r squared. This I can take my pen and paper and I can derive. I don't need to. I don't give a fuck what any. I don't give a fuck what you wrote. I don't give a fuck what they wrote. I like to derive stuff from first principles. Okay?
Sure.
So I can derive, you tell me to derive something, I'll derive it from first principles, and then I can go do an experiment. I can do it. That's real science. Okay.
Well,
Anything short of that is we
you're,
live in a world of influencers and bullshit and
I
all
agree.
that
I agree.
nonsense. So why don't we
Is
do
a
real
first
science?
principle that a three-axis gimbal holds rigidity in space? Is that a first principle?
What I'm saying to you is this, Dave. Let us call both set people together and make a hypothesis. You're saying the earth is flat, and if you fly this much, it's going to do this. And then have that discourse and design the experiment, period. And then get everyone to write their names on it. Write their names. I pledge I will execute this experiment. Their, scientific ethics
Sure.
to the letter. And I can facilitate that. Okay. And then you create teams. People are going to have to do it. They'll be filmed doing the experiments. And and all that data we publish. You have independent process, independent things. Everyone looks, and then we publish the results. Then you tell people, you just sit back and watch the fun. If you're right, you say, look, there's a result. This guy did it. This guy did it. You explain this. Okay. But I'm saying the experiment you're proposing, you're already saying, well, they're going to say this and this. Great. So then in that meeting here, let's say we do it on August 1st, 2025. You say, I know if I do this, and you're going to say this. And they're going to say, oh, yeah, we're going to say, okay. So what is the experiment methodology we design now that eliminates that argument in the future? You say? So you have to design that experiment up front.
I have it. I have it designed. We can discuss it when we have more time.
Right. What I'm saying, the call to action here, let us put forward, if you want, we can use this as a video as a basis. Let's choose a date. When do you think you can get your people?
August 1st sounds good.
Is that too early or too late?
Um,
We're in, it was what we're in
it,
January, February, March, April, May, June. Could be
yeah,
June,
it could be
summertime.
June, beginning of June.
Yeah. So why don't we choose a date in June and it gives us a date, June, let's see. Should we do it on a weekend? Should we say June 14th, Friday the 13th?
Maybe.
We could do, huh?
Yeah, I mean, we can pick a date. We'd have to take a look at our calendars.
Yeah,
But
so June 14th is a Saturday and a Sunday.
sure,
So we could call a meeting here in Cambridge, you know, scientific conference, experimental design conference, to design the experiment. And we leave out of that meeting with an actual agreed on experiment. We write it up, we propose it, and then we give it to other experts on both sides to attack that experimental design. Everyone critiques it. We do it openly in public. And then we meet again on July 12th, take all that feedback and update the experiment, and then do another meeting on August 16th. So everyone's had a chance. We do an alpha beta version, and then everyone says, yep, we all agree. You agree, they agree, everyone agrees. So in August, we have an experiment. And then we have teams start doing that experiment under the right conditions. We, in
sure.
fact, propose that experiment. We publish it, open source it, and publish it all and tell everyone to do it all over the world. Or I think we should do it in a particular place. Like we have the Quabbin Reservoir here. Or you can do it somewhere that you think. We have the Charles River here, right? wherever, everyone agrees we're going to do it at this location. We do it just like this, I think it'd be interesting.
Sure would
So
be. I mean,
I'm game for that, man.
there's some more particular experiments that when we have more time we could discuss. But
No, no, but I'm saying whatever you think, that is,
sure,
so people come, everyone proposes experiments, but what the outcome of June would be an actual experiment. Initially, everyone agrees on. We
okay,
circulate that experimental design. Everyone critiques it, attack. They said, "Oh, you missed this, you missed that." It'd be a working document,
I get it. I like
and
it.
then you come
Sounds
to,
great.
yeah. And I have a center we could do it out of. So if it's you, Dave, you go pick 10 people on your side. Um, I'll go find 10 people over at MIT and Harvard.
Perfect.
What do you think?
It sounds like a plan. I mean, that sounds like a good method to get it done accurately.
Yeah, and then we hold people accountable to follow that experiment and to participate. Like we'll have an ethics statement, a scientific ethics statement that they have to agree to.
I like it.
Yeah, let's do it. Let's do it in June. And we have your phone number, right, Dave?
Yeah, you do.
Yeah.
You should. I'll email it to.
Yeah, I tried to call that one number and it said this number's not the 203 number.
Oh, it shouldn't have. It should have gone right through.
Okay. Email my assistant, but I'm open to do that, man, because I just haven't had time to do this, but let's just follow scientific principles.
All right. Sounds awesome. Thanks for the discussion.
Yeah,
And
I didn't want to, the reason I didn't want to go into this is because I know there's tons of videos you guys have done. I think by this, we're like creating, I think with me, you have a chance to have a clean playing field, knowing it's going to be fair and coming up with an experiment. It may take us a little while,
mhm.
maybe a bunch of iterations, but we'll follow the scientific method so the swarm can't just blatantly discount what you guys are doing. And at the same time, it gives the swarm or the opposition an opportunity to lay out all their cards on the table up front. Versus if it's right, then they say, oh, this, oh, that, right? Let them put everything up on the table.
They're not going to go down calm without kicking and screaming. So,
Yeah, but we do it all up front.
all right, we'll give it a try. I
Document
like it.
open.
I like it. It sounds good. When do we want to talk next?
So send me your thing and I'll call you this week.
Okay.
And
Uh,
then I mean to get people here on if you want to do June.
all right. That sounds good. Let me talk to a few people, see who I can get to come and we'll
Yeah,
make
get the
something
top
happen.
10 people. I mean, there must be at least 10 people like yourself, right? In the world
I'm
who
sure that there
who
are. There are. There's a lot of controversy in the flat Earth arena because everyone's trying to figure out what this place is, and there's lots of options. One thing that we all agree on is it's not a ball because that's provable. The question is,
All right, so let's just go
what
to
is this?
very first,
Yeah,
I call it first
I
principles.
like it. First principle.
Very simple. I mean, if you want to make a dent, you take one thing, get super hyper focused on it,
Yep.
and go after that. And then you go to the next thing and the next thing. Okay, the next
Yep.
thing. Okay, etc. Otherwise, it's very hard to win in this game of whatever
Do you understand
game.
gyros? Do you understand gyros? How
Hmm.
gyros work, right? So
Definitely, yeah.
so gyros for an airplane fly like this. How about this? You put a gyro upright and
Hmm.
you spin it up so it's holding that axis and you point the plane east or west. Okay. And now
Hmm.
the plane goes and the magnetic compasses are going east. Okay. And the pilot just keeps that gyro straight because you got a gyro compass and a magnetic compass, right? And so he's just going to look at the gyro and keep that in that alignment. So the plane's going to go and east is going to peel off to the left, magnetic east, because it goes around the North Pole. So that's going to prove that the gyro holds rigidity in space, right? Doesn't prove the Earth is flat or a globe because in the northern hemisphere, when you dead reckon east or west with a compass with a gyro, um, west will curve off to the right and east will curve off to the left on both models. When you cross the equator, when you're south of the equator and you're going west, dead reckoning, Magnetic west is going to curve off to the left instead of to the right. It's going to curve off to the left, but it will curve off to the right because the Earth is flat.
Yeah, I have to think through that.
Yeah,
Can you show me where is Spain on your map and where on
let
your
me
proposed map and where is India?
let me pull up
Yeah.
a better map. Um,
And what
oh,
and what was the view of the world when Columbus sailed the ocean blue?
well, that's a good question. If you believe the story of Columbus. Um, so where's the map? Here you go. So what are we looking for?
Yeah, I just want to see where is Spain
Spain
and
would
is
be over here somewhere, right?
and
This
where is
the
India in
UK.
that map? Where is
India
India?
is over here.
Oh, okay. So if he had a flat Earth map, I mean, and
Here's Japan. Here's
yeah, so he would
Hawaii out
never have
here.
gone in that. Yeah, he would never have gone in that direction.
You know, who are we talking about?
I'm just talking about hypothetically, if Columbus thought the Earth was flat in that
Yeah.
model that you showed me, it doesn't make sense why he would have gone east, you say?
Yeah, I don't know if I believe in the whole Columbus
I mean
story
west.
because
Yep.
all
All
of
right.
our wait, let me just show you one quick thing and then I'll let you go. Um, so this is the flight from if the Earth is a globe, this is the flight from New Zealand, right? Australia's over here to Argentina. And Flight Aware says this is the shortest route, but that's not how it goes, right? The flight actually goes all the way up across the equator to San Francisco, all the way across to Houston, Texas, and it goes all the way down. That's the flight route. When you look at it on a flat Earth map, you got New Zealand, San
Yep.
Francisco, Houston, Texas, and Argentina. It's a straight line. There's tons of flight routes. All long distance southern flight routes match a flat Earth map. They do crazy things on the globe. In the north, it's kind of the same, but there is a little bit of a difference. But when you look at this along with emergency landings, that make absolutely no sense whatsoever.
David,
Where's what?
where is Africa relative to like Brazil relative to let's say Ivory Coast?
So here's Africa, right? Africa's here.
Yeah,
What,
so Ivory Coast is right down where you put
right.
your
And
finger.
here's Brazil down here.
So how do they no, but if you what's the tip of Brazil? Keep going, put your hand over there.
Yep.
No, right there, yeah. So how do they go from Brazil to Ivory Coast, which is right across? Do they just cut right
They
across?
cut right across there. There's undersea cables, internet cables that go from here to here, but there's
Right, but
none.
that
There's none that
but
go
that
from here to here or from here to here or from here to here because it's too far. But on a
uh-huh.
globe, they're right next to each other. On a globe,
Yeah.
they're all wrapped around the bottom of a globe.
Well,
Undersea cables prove the Earth is flat. Airplane flights prove the Earth is flat. Everything proves the Earth is flat unless people are just unwilling to look.
mhm. So where
Right?
do undersea cables go for Australia?
I'll show you. Cables. So this is a map of all of the cables, how they go. So Australia, they go all the way up to the north, and then all the way. Well, they go all the way up here and then down. Right? This is just not a great map, but the none of them like this and this are close together. These three things are all close together, but there's no cables going there because it's over twice the distance that it shows on a globe, three times the distance. And when you look at all these cables, they make
Well,
absolutely no sense on a
well, that's
globe
a
on a
different issue. I mean, yeah,
yeah.
that's just the way that they did the whatchamacallit
Well,
themselves.
I disagree. I mean, everything matches matches a flat Earth, right?
Okay. All right, Dave, I got to go.
All right,
Um, but this is I think I just want to take a clean sheet
I get it.
and just go to experimental physics, just do the basic stuff
Right.
and get people to,
Maybe we can have another conversation and discuss my gyro experiment because I think that's a cleaner
okay.
experiment because there is no excuse for it.
Well,
There's
no,
no
what I'm
way.
saying is whatever ideas you have, it should be done um in collegially with
Yeah, no,
pro
I
and
agree. So I think you and I should agree. Like, hey, that sounds like a good experiment. Let's run it by
well,
everybody.
what
Let's
I'm
have
saying
this
is I think
conference.
what we should do is we should have them propose two experiments you or three, you guys propose three, and everyone works together to come up with one.
I like it.
So I'm saying my theory on this whole thing is, unless people concur on one experiment, we're not going to make any headway.
I got it.
So,
I think the gyro experiment is undeniable.
okay, cool.
Yeah.
All right, Dave.
All right. Thanks.
Great. Thanks, Dave. Thanks for the time. Sorry I was a little bit late. Apologize.
It's okay,
Please
man.
don't take it. Yeah.
Have a great day. See ya.
Thanks, Dave.
Bye.
Bye.